Hello everyone, we are Team 25 and we have designed a programming language named ROCH for the subject Emerging Languages and Programming Paradigms. The team members are Aditya Kumar, Nishiti Sawant, Anchal Mahajan and Mahima Gupta. Throughout this presentation, we'll be talking about how the introduction of the language, the tools used for its development, the features it has, the proposed design, the grammar, compiler, the intermediate code generation, the runtime environment, and code execution. ROCH is a programming language well suited for beginners. It is so because it's a very simple and concise language. It follows the imperative programming paradigm. Java has been used to create the compiler and the runtime environment. It uses mainly two data structures, hashmap and stack, for the symbol table. The tools used for its development are, for the lexical analysis and parsing, we have used Antler 4.7, and the intermediate code generation is done using Antler in Java. Runtime environment used is Java 1.8. Now Aditya will be talking about the features of our language and discussing the grammar.
Hello everyone, I'm Aditya and I'll be going through the features and the grammar of our language. So these are the following features that are supported by our language. So we have data types, which are number for the type integer, and we have bool for boolean type. We also support the normal, arithmetic and conditional operators like multiplication, division, addition, subtraction, along with less than, greater than, less than, equal to, greater than, equal to, and so on. We are also handling the precedence of the operators in our grammar. So we are able to actually evaluate the expressions that are complex, like a plus b into c divided by a into f, according to the rules that we have in our grammar. So the result that we will get will be according to the rules of precedence. We also have conditional constructs in our language, which is check otherwise, which is almost on the same line as an if-else. So we check for a condition, and if that condition turns out to be true, then one block of statement is executed. Otherwise, the statement in the otherwise block of statement is executed. We are also supporting nested check otherwise. We also have an iterative construct in our language, that is until, that is on the similar line as while. So until construct runs until the expression that is passed to it is still true. So this is the high-level design of our language that we have proposed earlier in our phase 2 of our project. So we will have a source string that will be we will have a source string on which we will be performing a lexical analysis. After that, we'll be doing the syntax analysis on this. This part of it is done by the Antler 2 that was explained in the earlier part by Anchal. Using the Walker functions in that Walker classes in that generated by Antler, we are generating our intermediate code, which is then fed into the runtime environment built by Java, and after that after that the runtime creates the desired output based on intermediate code. Yeah. So now we'll talk about our grammar. So our grammar has our ROCH has a context-free grammar. So these are the basic overview of our grammar that we have. So the grammar gives us a starting block of code that we have. So in our grammar, which we'll be seeing later, we have like start to identify the start of the file, and then we have a block of quotes, then we have a terminate file to signify the end of file. As I said, block is a set of statements. A statement can be variable declaration or assignment or a display function, or we have our check, so we have our conditional construct that is check condition, or we can have a iterative construct. An assignment can be an arithmetic expression or a conditional expression. We have data types which are num and bool, and we also have display, where we can display any arithmetic expression or conditional expression. So I'll be going through our grammar in detail now. So this is our grammar, which is the ROCH grammar, and we have the grammar start. So this will denote the starting of our grammar. This is the block of statement. This is the terminate. A block of code can be a set of statements The statement can be a variable declaration or assignment, a display function, check condition, or an until loop. An assignment, we can have an identifier which is getting assigned the value of another identifier, an arithmetic expression, or conditional expression. An arithmetic expression, we have multiplication, division, addition, and subtraction, or we can have an identifier or an integer. In our conditional expression, we have greater than equal to, less than equal to, greater than, less than, an identifier, and a bool. Our data types are num and bool. We have a check condition where we check, then otherwise, then we have a check-in. This is the basic structure of that conditional statement that we have. Then in the check, we have the conditional expression, then we have the block. In the otherwise, we have otherwise and the block. This check-in signifies the end of our conditional construct. Then we have an until loop where we have until and until end. In until, we will have until the conditional expression that we have to evaluate so that we can keep executing that block of code which we have over here. And we have until end. We have our normal variable declaration where we have the normal data type and identifier like in most language we see. Our identifier can be a set of characters and followed by a set of integers or a character. So it has to start with a character. And our set of characters can be from A to Z and capital A to Z, and we can also support an underscore. And our integers can be 1 to 9, and we can have when we also have digit that is from 0 to 9. Bool, it can be either be true or false. Display, we can display an arithmetic expression or a conditional expression. We are ignoring all the blank white spaces that we have, and we also have comments in the form of double exclamation mark. So what we have done here is that we have created a regular expression over here. So this is the double exclamation mark is for a single line comment, and this exclamation mark followed by dash dash, and it ends with the dash dash exclamation mark is for multi-line comments. Thank you.
Hello everyone, I'm going to talk about the implementation of a compiler. Before we start talking about the working of our compiler, I would like to give you a little bit of information about our grammar. So our grammar is going to be passed in a top-down manner. We are going to take only .rc files which are going to be fed into the antler to give .rcic files. So let's go to the actual working of our compiler. So this is the grammar, ROCH grammar.g4, which we created. So we run the antler tool over it, and you will see that the build is successful. This shows that there is no kind of redundancies in our grammar, and there are no errors. One more thing that the antler 4 tool does is that it makes a walker class. So you will see that inside the target and generated source folders of the antler 4 class, there are 4 kind of different files created. These files are the parser class. The parser is the main class which converts the RC files into intermediate files. There's a listener class and a base listener class. So the base listener class just extends the listener class. We are supposed to edit this file, but we did not want to use all the functionalities, so we created an intermediate code generator which extends the base listener. So the intermediate code generator has 2 main data structures, which is the symbol table and the intermediate file. The main function of the intermediate code generator is to make exit and entry level functions, which takes in the RC files, puts all the tokens into the intermediate files, which we'll come to later, and puts operators and variables into symbol tables. This intermediate code generator is called by the parser function, which eventually creates an intermediate file .rcic, which is given further to the runtime. So I will show you the working of our file. So this is our jar, and this is our RC file which contains our grammar. I will run it, and you will see there's an output to given to it. You will also see that a RCIC file is created. This was the file that I put, and this is the RCIC file which gives the intermediate code. I will further explain. So I'll tell you what the intermediate code actually does. So it creates tokens for any kind of identifiers. So like a num a becomes a num a, and a assignment operator will become a push operator where it shows that 15 is supposed to be pushed into a. So that's what a assignment operator does. We can go to see a little bit more complex variables and function expressions, sorry, like c equal to a plus b, where you require accumulator, which is also present in our function. So the accumulator creates accumulates the variables of a and b and adds them, which are later pushed and printed. So in short, I'll give you a total overview of what our intermediate code generator does. It takes in high level language, which is passed through the Antler 4, which creates a Walker class and a .rcic output, which is given to the runtime for the further execution of the output. Thank you.
Hello, I'm Nishiti, and today I'm going to explain about the runtime of our programming language. So, as Mahima explained, once a language is compiled, a .rcic file is generated, which contains our intermediate code. This file is then passed to the runtime. In the runtime module, there are four Java classes: run roach, pass roach, execute roach, and symbol map. In this diagram, you can see how they are connected to each other. So basically, the .rcic file, that is the intermediate code, is passed to run roach, which generates array lists and tokens. These tokens are then passed to the pass roach, which calls functions from execute roach. The functions in the execute roach accesses the symbol tables and manipulates the symbol tables and performs operations and then gives the required output. So basically, I'm going to explain you with the code. So in run roach, we pass the file, the .rcic file, that is the intermediate code file, to the run function, which calls the read file function. In the read file function, the file is passed line by line, and each line is stored in the array list called record collection. This array list is then passed line by line, and the tokens are passed to the pass roach. So basically, if there's an intermediate code saying add a b, or like add c a b, basically, so the addition of a and b has to be stored in c. So what we do is, when we pass it, add, like add is an operand that is always at position 0. So that is passed to the pass tree, which checks the token list, and and there's a switch case. So that operand tries to match to each, finds which case it is. So now I'm giving an example of add. So here there's a case called add. So this will call an function from execute roach according to the operand. So execute roach dot algebraic operators will call a function algebraic operators, to which the add and the token list will be passed. So basically, as I told you the structure, it will be add c a b. If c is a resultant variable, so that will be at position 2, sorry, position 1, and a and b are operands. So the operands, so those will be at position 2 and 3. So that way, in the add, we use update value, and the variable c is updated by adding the variables a and b. This is done using update value function. The update value function basically checks the symbol table for the value of c, what is the initial value of c, and then updates it to the new value of c. Also, when we are adding, we use a get value function here for getting the value of the operands, because if we are doing add C, A, B. So we need the current values of A and B. So we use a get value function where the get value function just takes the symbol table, scans through it, and finds the current value of A and B. So that current value, we compute the addition of this current value and then update the value of the resultant variable. Similarly, all the other functions and operations, loops, and conditional statements are performed in a language. Next, Achal will explain few of the executions of a language. Thank you.
Hi everyone. I will be demonstrating the execution of a programming language through simple programs. As you can see, this is a sample program which starts with the keyword start. A number D is defined and is assigned a value 1. It is further displayed on the screen. Similarly, num E is defined and is assigned a value 2, which is displayed on the screen. Finally, we define a num R, which is given the value which is assigned this expression. As you can see, this expression has operator precedence and it displays R. The program ends by the terminate keyword. When we go to the terminal, it's very easy to execute this program. Our project is a Maven project and can be easily built by using the command mvn package by going to the folder which contains the pom.xml. Later, we can easily execute this jar by typing java-jar ser502 underscore team25.jar space the name of the program we want to pass as a command line argument. When you run the program, the answer is displayed 1, 2, and 4. As you can see, the value of D was 1, E was 2, and R is 4. Secondly, I'll be demonstrating a program which has the check and otherwise condition. This program has a similar structure and it starts with the keyword start. Num A is defined and is given a value 11. Num B is defined and is given a value 5. Then we check if A is greater than B. If it is, then A is displayed, otherwise B is displayed. The check block ends with the check end keyword and the program terminates. Similarly, we'll be executing the same program by typing the same java-jar command followed by the name of the parameter, that is our name of the file. So the answer is 11. As you can see, 11 is greater than 5 and display A prints 11, which is displayed here. The last program that I'll be demonstrating is the while condition. Similarly, you can see this has the same structure as our previous programs. It starts with the keyword start. Num A is defined, which is given a value 10. Num B is defined, which is given a value 5. The while loop is the until loop is synonymous to the while loop, where we can give a condition in the starting where A is greater than B, and it displays A, and it decrements A for every execution. The until end keyword denotes the end of the until block, and the program ends with the terminate. Similarly, you go to the terminal again to execute the program with the same command followed by the name of the file. Here you can see it starts with 10 because A was 10 initially, and it decrements till A is greater than 5. So answer is 10, 9, 8, 7, and 6. We have two other programs in our repository which show the sample runs, but I'll be covering only the 3 programs during this demonstration. Thank you for watching this video.